Okay, I think we'll go in and get started. Let me go ahead and open up in prayer and I'll give a sense of what we're going to be covering today. So, dear Heavenly Father, Lord, thank you for the chance to be working with each of the students in this course, Lord. Pray that this can be an enjoyable time of getting an introduction to engineering or computer science, or for those that have been here for a while, have a way of synthesizing this maybe in some ways that they haven't done so far. Pray that you would help each individual to get the job of their desire or opening a company that they wish as they finish up their time at EPU. Also, Lord, I pray that you would help them in their spiritual formation, Lord, that all the time that they've been able to study scripture, Lord, that they can cherish that in their heart and be able to leverage that and see how it's going to apply in their day-to-day life and how they can be thinking and applying theological concepts. Give them interesting and creative ways for faith integration. In Jesus' name we pray. Amen. Okay, well, today I'm going to continue in what we're covering in our main textbook, Engineering Fundamentals, but I'm going to do a little bit of a twist for this section on engineering fundamentals. When I was contemplating using this textbook, this is the one section that it gets a little bit complicated. And so guess what? We live in a complicated world. Part of that we can't get away from. But also for what we're trying to cover in this course, especially since we have a mixture of engineers and computer science, I'm trying not to overwhelm folks, but give you a nice way of getting introduced to the major themes. And so for these chapters, I'm not going to go through in as much detail, but I'm going to supplement it with another textbook that I have some lecture material that I've used before in other classes that I've taught similar to that. And so we'll go along that way. And also wanted to continue to encourage conversation and teacher-student interaction, especially on Tuesdays when we're here face-to-face. And so I did put out an announcement where I'm trying to prioritize that on Tuesdays, let's spend time together in the same room. And so having a dialogue that we can have on those terms. So I will be taking some of our time to have some of that dialogue on Tuesday, and Thursday will still be more of our lab day. And I will be trying to showcase some tools and things like that as we get more into the latter parts of the course. And so for today, we're going to be talking about force and related variables in engineering. And so just keep in mind, an engineer or computer science is like you need to be aware of these physical quantities. It's not the same as being a physicist or a mathematician. It's more applied math, it's applied physics that you're using for a purpose. Think in terms of technology and how you're leveraging technology to accomplish what you would like to do. And so that's the main focus that I want you to be thinking about, these physical quantities that we're getting our heads around. So we have these two chapter objectives, and as a result, the way I'm going to be doing, I'm going to focus mostly on these charts and cherry pick a few other ones, and then quickly go over to another set of charts that will be talking more about the engineering and computing method, another way of thinking about that. And we had a couple volunteers of folks that wanted to have their projects showcased for what we'll be covering. So we'll focus on those. And hopefully I'll get some more volunteers so we can continue to have some dialogue and have it going around our project work. So in this chapter, we'll get a chance to be understanding force, explain what it is meant by force, and give examples of different types of forces in engineering analysis and design. So force is a real fundamental concept that we need to get our arms around. Force is how you make things happen. You can think of anything. If you're pushing a door open, you have to apply force to that door. There's a lot more to that, but that's one way to be thinking about it. I'll spend time to go through this one chart summary of Newton's laws of mechanics. You guys familiar with Newton's laws, or at least you've heard of Newton, and so you've had an idea. So mostly you guys got a sense of that. So maybe it'd be a little bit of a refresher. We'll think about moment and torque, force acting at a distance. And so that is an interesting concept that we'll get a chance to be thinking about. Momentum and torque. Some of you, maybe you worked on your car sometime or another, and there's something called a torque wrench. So basically, you have this wrench, you're trying to tighten a bolt. And one of the way these torque wrenches go is when you set it for a certain torque, and then when you get to that point, it goes click, click, and you know that you've got it to that torque level, and you don't want to over torque it. Some of that gets into mechanical engineering in terms of how you want to put stress but not strain on that bolt and have it tightly have a tight connection. So this gets into describing the tendency of an unbalanced force that results in rotating, bending, or twisting an object, and it also explains how it is quantified. So force acting at a distance. So you can be thinking of a torque wrench. You got this lever arm with this wrench, and so you can be applying more torque, more force to get that connection even tighter. So once again, here we see this term again, force acting over a distance. I mean, this is in terms of work. For some of you that have a long drive here, you could say that force over a distance, and so you have to drive 50 miles. That's a lot of force that is had to take place. And for most of you, it's probably using gasoline. Some of you, it might be an EV car. And so it's electrical energy, kilowatt hours that are stored that are converted into force, and you're acting over a certain distance, maintaining whatever it's needed to have you go over that distance. Starting from zero to get an object moving is going to take more force. So this describes a tendency of an unbalanced force that results in moving an object through a distance, and it also explains how it is calculated. When we have pressure and stress, force acting over an area, so how you can think of like a balloon, and you can think of it as a blow-up balloon. And so one of two things are going to happen. If it's like made out of rubber, it's going to get bigger the more you blow air into it. But if it was somehow constrained, it means that the pressure would build up in that fixed area and get to be higher and higher. Your tires on your car is something that you get it up to so many PSI. That's an example of pressure. And so this helps us to explain how pressure and stress provide measure of intensities of force acting over areas. And finally, linear impulse, and this is force acting over time, describes the net effect of an unbalanced force acting over a period of time. Maybe you've seen like the handbells. I can just think of a more musical example that they ring a bell, and it based on the acoustics, the way they've set up with that bell, it's going to resonate for a while, and you'll get that sound going over time. And so it's responding as it's vibrating. That vibration is slowly going less and less, but those are tuned just like a tuning fork. You ping it on the table, it's going to be, A or whatever note it is. And it's just going to get fainter and fainter over time. Or you can have an impulse response of a couple other source things, but that's just to give you a general sense of what that is. So the simplest form of force that represents the interaction of two objects is a push or a pull. So if you ever played tug of rope, you could be thinking of that. And whatever team has the stronger folks, it's likely going to be getting the other folks to go in their direction. So there's a variety of different forces. There's a gravitational force, there's magnetic forces. Those are all things that are there as well. So we get a chance to be thinking about those here. We talked about units of force, SI units previous, so I won't get into that. You have the spring forces, and so you can put pressure on a spring and then you release it, and that force is going to go out. And so this is an equation for that. If you have a garage door opener, my wife and I, our garage door, it has these great big springs that keep the garage door open. And so that just gives you an idea of the kind of force that it can manage to keep that garage door open and then have it nicely close without too violently going down when you want it. So then we have Newton's laws of mechanics. And maybe mechanics deals with the study of behavior of objects or structural members when subjected to forces. Kinematics, kinematic equations, maybe you've heard of that if you've been taking some physics courses. The behavior of objects and objects' linear and angular displacement, velocity, acceleration, deformation, and stress. An object is an object that is defined by its geometric characteristics and material properties. And so here's Newton's three laws. And so Newton's first law, if the given, whatever is at rest stays at rest, and whatever is in motion tends to stay in motion. This is a longer way of saying it. Here, I won't give that to you, but you can read that. The second laws of motion is F equals ma, that's the mathematical form, and the net effect of unbalanced force is equal to mass times acceleration of the force, or F equals ma. Third, Newton's law is every action there exists an equal and opposite reaction. So if I'm pushing against the wall is pushing against me at the same level if we're staying in a balanced situation. If I wanted to start to move away from the wall, I have to have a force greater than what is pushing in the other direction. So those are pretty common things that I think you all have heard about. We have moment and torque. In this first example of this force acting at a distance, I mentioned a torque wrench as a way of thinking about that. Here we have the concept of work. So it takes work to get your car to move from home to school, to give you an idea. So that's another area that we're getting a chance to explore. Pressure, talking about volumes, compressing gases into a same volume. And so that's what we get a chance to be also thinking about. That's part of this. And so it also gets into weather systems. Like right now, it's pretty warm here. And so we actually have a high. So for us, this would be more, say, of getting what it'll be in a couple months when it's winter, and you get a low and a pressure low. And so things would tend to stay at a lower temperature or high. You get things that are flowing, that's maintaining a heat wave in that local area. And I'm not going to get into the meteorology. That's a formal term for weather systems and weather prediction. How the different winds and the way that things occur. The weather fronts you could see with symbols like that. But in low pressure, that things tend to go towards the low and away from the high. Those are some observations, and basically they're pressure gradients that's causing that to take place. And then finally, linear impulse, an impulse response. Maybe some of you have heard that term, maybe more of the engineers. And if you haven't heard it, it's probably something you'll hear about in the future. You have some kind of a step function that you apply to something in your physics course. It's likely you'll have something you impart a large force, and then you see how it acts over time. We're just finishing up baseball season. And so basically when a batter hits the baseball, this gets into a two-dimensional kinematic equation. You hit it, and if you know the velocity and the angle, you can calculate how far that ball is going to go. And so that's what they do. They tell you the exit velocity and the angle, and they come up with these predictions. Even though they don't have somebody catching the ball right when it would land, they can give you that estimation with all the other information that they know to do that. So force is an extremely important thing that we think about in terms of engineering and programming related types of activities. I think in engineering, it's quite clear that this is, why do we have technology? Why do we have cars? I've been using that example a couple of times because it creates us the ability to do things with less energy. It's a lot less energy to just put your foot on the accelerator pedal versus if you had to run or walk or ride your bike from point A to point B. All of those are rationales for where we're using force to better our lifestyle. For computer science, it may be more focused on, well, if I'm applying this type of force, am I actually going at the rate of speed that I want? And so you're thinking it more from a software center point of view in a cyber physical world. What are the measures that you're taking that you can get a chance to get some feedback that this is occurring and maintaining operation as we expect it to? So that's a really high level 15-minute overview of what we're thinking about in terms of force. Any comments or questions on that? Okay, well, let's do an experiment today and see how it goes by doing a quick introduction for that. And then let's focus on just a handful of charts that I wanted to share. This is from an older textbook on introduction to engineering that I used a couple years ago. And I'm going to be picking some information here. And so this is an effective problem solving technique. And so what I'm going to do is I'm going to introduce this, and then I'm going to flip over to talking about our projects, see if this helps us to quantify an approach for solving these problems. I've given you the outline for what you would have for your midterm, and I would welcome us having conversations between now and then so we can actually be taking some of our class time to flesh that out and refine the problem. So here is a formal technique to help for solving problems, and here are the 4 steps: need, know, how, and solve. And I'm going to explain each one of those one at a time. And the method breaks the problem into 4 constituent parts that are easier to formulate than the overall problem. So let's look at them a little bit at a time here. First, a little bit more of an introduction. Engineers and computer scientists of all disciplines are often challenged with unfamiliar problems. By breaking them down into a systematic methodology, many, quote, impossible problems can be solved. So maybe some of you, when you were looking at your project, it says, well, this is just undaunting. I don't know how to do that. Well, this actually gives us an approach for how to be thinking about that. And some of you have thought it's a huge problem. Well, first of all, we can bound it, and you can either have it as a high level kind of study or get into more details. By systemizing your approach, you will leave an auditing trail for all those who later work on the same project. So guess what? You're leveraging work that has been done by others. I'm going to show you an example of one article I found of converting plastics into oil. That was one of the themes that we spoke about, and had a volunteer for us to be using that for today. And it also can be helping you with your grades, both for this course as well as just in general, to be thinking critically and effectively. So let's take them one step at a time. So first, for the need. The first step is obvious. Read the problem very carefully. Look at what is being sought. Don't try to solve it now. Just write down what you are seeking. Do you have a clear sense of what your problem is? So let's just focus on that. What are you guys working on with your projects, and what do you think that the need is? Anybody want to give your 2 cents of what you think the need is for your project? I'm going to be pulling up that slide in a few minutes, but I don't have it up right now. Okay, well, let's take that one example, since we were talking about it a little bit, the idea of turning plastic into oil. What do you think the problem is? How would we start to frame that? Anybody want to put that into words? Good. Mm-hmm. Yeah. So like there's multiple ways that we can be thinking about that. There's if I understood what you were saying, there's the shortage of oil, and so this is a way of making more oil available. Is that right? Yeah. Recycling is an important thing, and I'll show an article that I found related to this. So that's one example of a need. There could be half a dozen or these different things. And so maybe you have a hypothesis, and then you look at what you have, you might adjust that a little bit. And so it's okay to iterate. So the first thing is you need to come up with a clear, what is the problem statement? What is the need? And it's okay for you write it, and then maybe you're going to refine it. The next thing is no, what do you know? What are the knowns? Look at what you have been given, or look at what is available resources if not explicit in the statement of the problem. And again, don't try to solve it now, just write down what you know as a second step. Okay, so we're trying to turn plastic into oil. Well, what types of plastics are available? How much are there available? What techniques have been established to date? What type of resources would I have? Would I be able to apply heat to it? Is there other kind of chemicals or things that should be thought about? So first of all, having a problem statement, thinking about what are the givens, what are the things that you know about. Then we have two more. Then we start to formulate your intended approach. Now you're getting more specific. It may be trivial. How many apples can you buy for $17? Or it may be an equation, for example, E equals MC squared. Or it is if the need for a spreadsheet analysis still don't solve the problem now, but you're trying to think about it. So spreadsheets can be quite extremely useful. And so much so that's going to be one of our lectures that we're going to be talking about is the utility of spreadsheets. And so we'll come to back to that in more detail, but you can be thinking of all these different possibilities. And so you can, have 3 or 4 options, have a few measures of how you're trying to compare that, and then finally come up with what you think would be the best way of doing it. And the fourth, and the last step, what your does what your instincts told you. And then the first step is to go ahead and to get to a solution. So the way the systematic thing here is you're delaying just jumping into solving the problem before you first of all know what the problem is. You figure out what it is that you actually have available. What are the knowns? What are the things that you can apply? Then you figure out what is your method? What is your approach for implementing, for solving it? And then the final step is just then getting into it. So that's what I want to have us to be thinking about as we move forward with the things that we're going to have in our discussion. Any comments or questions on that? You see how this is related to what we had in our main textbook when they talk about problem solving, maybe not as many steps, but you can show this general way of thinking critically, coming up with an approach, and then you utilize that approach. Okay. Well, let's pull up our project list, and then I'll work more specifically on an individual one here to start out with. So here's our project list, and as of our last meeting, we had a couple of volunteers of ones that wanted us to focus on your projects. And so the first one we had was recycle plastics to extract oil. And then the second one was a solar mobile phone charger. And I put announcements with some information that I found. And so the first one was an article that I found of a technology that was advertised. And so I'll go to that next. So we already had a little bit of discussion about the first one is the need. What is the need? What is a problem statement that we're trying to focus on for this particular application? And so there's a shortage of oil. This is one of the ways that we could start to fill that gap. There's also the imperative of trying to clean up the environment. And so if you can make a cost-effective way where there's a return on investment to clean up the excess plastic that's all over the place, this could be a helpful thing that we could be doing. So that'd be the first step. Anything you want to add to that? In that project, or anyone else has a comment on that? Yeah.
Yeah, you're right when you say, it's a method I guess, closing that gap. It's a method to close the gap. It's just,
Well, this is a place we can practice. So
it's a method that's used to aid in it's a method that's used to help combat the low reserve on fuel because, like I said, I know that fossil fuels, they're running really low right now, and they're still depending on them. So that can help our while also being environmental friendly and helping combat pollution. So that's basically
good. Well, just so we can make this so we're talking about more than one project, maybe we can get like a computer science project. One of you guys, if you want us to flesh out yours. Paris, you talked a little bit about yours already, and we started to finesse it a little bit. You want to give us your thoughts where you think perhaps this approach, this need, know, how, solve might be helpful for you to be figuring that out?
On the plan for the athletic department.
Mhm.
As far as like the schedule of like the time management. So it would be figuring what exactly to produce to make it development for all the athletes and then solving the issue.
Yeah, and maybe let's just focus a little bit on that. No, so what are the things that we could measure? How much sleep they get? What is the nutrition that they get? How much water are they drinking? How much strength exercise? All you come up with a set of things. All of those are things that you can measure and you can calculate. And maybe you come up with a metric, like we're just getting into football season and they have like a quarterback rating, you know, batting average, or for what you're talking about, whatever would be a metric for how is their 100-meter dash or their jump for trying to do something like that. Those are some things that you could be measuring. So the things that they do: sleep, water, food, nutrition, exercise, strength training, as well as performance metrics that you could, all of those are things that you could see that you could easily calculate. And you could also see, start to pull out some relationships. It's like, okay, if I got like an extra hour sleep, so maybe instead of depriving yourself, making sure you're getting 8 hours, not 8 hours in the bed, but 8 hours of sleep, and 3 meals a day, keeping your blood sugar at the same level, making sure that you're getting proper nutrients that you need. All of those things could be stuff that you would have. And then how, maybe you want to have looking at for a dozen people that you're going to be monitoring, maybe with a beta test, and you start to have like a spreadsheet where you input all these things. And so they email you this information, or it's automated with an app, if you have like a phone app related to your to-do list. And then you can solve and say, you're on track. Based on what you have shared, it looks like your performance is actually increasing. And so by these variants that you did over the last month, we can see that it's making an impact. So that would be an example of thinking about that. So let's go back to our recycled plastics to extract oil. Let me introduce this article. And there's nothing sacred about this article, but just one that I found. And one of the things that I put in my comments related to this is the only bad thing was that it didn't have any references. And so maybe this is more of an advertisement, but I still thought it was instrumental for the topic that we're trying to get our heads around. So the title of this was a new method for turning plastic into oil, the conversion of mountains of plastic waste into oil and new products could help address gaps. And so this is referring to Japan's recycling efforts. I think Europe and other places like Japan, they have limited locations for landfills and stuff like that. So recycling can be more of an imperative just because of, geography. But we want to be getting away from stuff like this, where there's just all of this plastic, or having it in the ocean. And those are some things that this is trying to give us some perspective about that. So despite global concerns over the accumulation of plastic waste, that the drive to produce new plastic shows no signs of slowing down. According to this OECD data, the world's annual plastic reduction has doubled in the last 2 decades. The versatility nature of plastic, its lightweight, durability, and ease of molding is hard to rival with any material now or in the foreseeable future. So this is something that is a concern. And so here we have Asami, a professor of the University of, well, I'll just say it's in Fukuoka, Japan, but limited fossil fuels and environmental concerns demand a shift in materials sourcing and waste management. So that's exactly what we were talking about earlier, just related back to our need statement. They've got it pretty well articulated. And so now if we're doing our independent study, we need to be leveraging, well, here is something that we have. So Sami is collaborating with a recycling technology company, Environment Energies Company Ltd, based in Fukuyama in the greater Hiroshima area. The company is pioneering a method for converting plastic waste into crude oil using catalyst. And so it's not just using heat, it's also using a chemical reaction to facilitate that process. And so you can read through this. So the concept of converting plastic back into crude oil is not new. So let's just think about that. So crude oil has been put into a lot of different hydrocarbons. And one of those is plastics of various types. And so there's all kinds of plastics, nylon, or you name it. There's various types of things that are just different hydrocarbon ways that they're creating long molecules with this information. So past efforts have centered on a process of applying intense heat in reactors to break down plastic molecules. So I mentioned that already. So that does work. A series of Japanese firms began building plastic to oil conversion plants to bring the technology to real world application. However, due to fires and industrial accidents and economic problems, these plants were forced to close. So thus we had a viable option. So we don't get into it too much in this, but it comes up a little bit here with the spreadsheet. You can be looking at analysis of alternatives, which is a concept I'm going to come back to a little bit later, is which option should we use? This gives us a chance to be thinking about a particular option. So the name of what they called it, they call it Hiccup. So the kind of nice little name, which uses catalysts already employed in petroleum refining to distill heavy crude oil molecules into lighter molecules such as gasoline. So heat, but not intense heat, plus a catalyst can lead to gasoline. So it was developed and patented by Fukuyama Moto. And so now they have this realized. And so at 380 to 450 degrees Celsius, the catalyst attached to the plastic surface breaks the materials into smaller pieces, eventually converting them into hydrocarbon gases. These are then concentrated into crude oil. And so that's just a little bit of a synopsis of that. So let's kind of look at it. So let's pretend we've got like our statement here. We've gotten the how, we've gotten the need. We're figuring out some of the things that we have in terms of the know. So now we've done some research, and here's an example of one of the resources and one of the technology we would like to leverage. What do we do now? You want to talk about that? And then others, feel free to inject. So we have this process, which is a shorter version of what we have in our textbook. Need, know, solve, how. This insurmountable problem of turning plastics into oil. We've seen an existence proof that's out there. Okay, now we see two options that are available. One is just applying heat, another is applying heat with a catalyst. What do we do? Are we going to propose another option, or are we going to just continue to do more surveying to gather this? And so some of you, this was where your research project might go, is like, I just may want this to be a research project because I don't know much about it. And so it may just be coming up with those lists and having a list of criteria of coming up which might be the best option. And that's as far as you go. Others may go further and say, no, I want to actually go with this one particular approach and do some analysis. I'm going to use MATLAB, I'm going to use Python, whatever you want to do data exploitation of different things that are out there in terms of the things that maybe from a more software engineering or computer science point of view of just trying to get some data analytics and metrics. Those are all possible. Does that help? So what do you think you would want to, as of now, it's not holding you to it, but I'm just having you think about it. What would we do with your project related to this new information?
Survey, like, research, so both possibilities, see how, let's say, like, we're just using me, how does it differ from using me and what kind of.
Yeah.
Do a series of tests over a period of time.
Mm-hmm.
It's certainly like you could grab and see how are they different or how are they similar.
Mm-hmm.
And I guess importantly, how effective are they? Do they actually work? So
Right. Mm-hmm.
Discussion and see like which one is the most effective or which one should we just.
Yeah.
Or should we I guess think of another alternative is what you're saying. I guess there are, yeah, you could also say like why use plastic, why not use something else?
Mm-hmm.
Like even plants have oil in them.
Yeah.
So
Mm-hmm.
could that be an alternative? But that would just be like another branching out to another thing.
Which is perfectly fine. And so that's both good news and bad news. It's like you can come up and then you find more options instead of getting narrower, you're getting wider. But that's still true. And so you may end up having to refine your research question with that, but still catalog everything that you have that you found out as you're doing your research and you're refining your need. So I think that sounds like you got a good thing. So general thanks for everybody. doing some searches. You can go to the library, you can go to the library website and just do a search within that. You can do things like going to Google Scholar. You want to find some, I would recommend scholarly, peer-reviewed journal articles that give you information. And then another important part of that, it also gives you references. So you can see who are they quoting. And so that can be a way of starting to give you a good basis for figuring out what's actually been done at a scholarly level. This one article, I think it's accessible and it's good, but if it's an advertisement, that's probably not what you want. It also doesn't have any footnotes, which is unfortunate, but that's just another couple of things that I can be pointing out. But this, it does give a reference here for the environment, energy in Japan. And so we're getting a chance to see some of the things that they're thinking about. And so it still, I think, is a good article for us to be looking at, and it does share some forms of technology that we could be leveraging. Any other thoughts? So we got the first couple of steps. You can do a little bit more research. And so the third step is how you want to be thinking about that methodology and how you're going to actually do something with all of this information. Formulate your intended approach. And that can be part of what you put into your report, okay? Let's go over to Canvas for a minute. I put all this extra information in here. So does this get bigger when I do that? Okay. So here is like that first part of you wanted to be defining what you're going to be doing. Define a research question, state a hypothesis, develop a research methodology, collect information, analyze gathering information. So that's related to this this first step, the how. We see that. Here is the design and computing process that we have in our textbook, our main textbook. Recognize the need. So here we have that same word, the need, problem definition, research and preparation, then conceptualize, that gets into the how, coming up with a synthesis of what, as you've started to figure out the results that you're coming with, what you created, an evaluation, which is better, any optimization that might be required. And finally, having ability to present the results. And then I had the outline for what you can be using. And with our discussions we've had on this already, it seems like this outline works okay for both engineering and computing projects. So I'm happy to do that. That's the case. So any other thoughts or comments on that? Okay, the other one that we had here was a solar mobile phone charger. And let's have us have a little bit of a discussion about that. Please remind me whose project was that? Trying to. Okay, well, then we'll just have to defer that. But one of the things that I did is I was looking at solar chargers. And so there are a variety of those that are commercially available. So from that point of view, it's something that can be done. I'll just kind of throw in number 2, an automatic solar tracker. What if we wanted to have it a little bit more higher performing? It's just not flat on the ground. And as the sun, anybody have solar panels, your family, or you've seen solar panels? So what happens is the angle of the sun that's hitting those solar panels, when it's going at a grazing angle, it's not producing much electricity, but it's when it's straight down, that's when it's going to be getting the most electricity. So if you were to track that, you can actually increase the amount of solar energy that you're going to be producing from those panels. And that's the motivation for having that tracker. So it could actually make this mobile charger perform better if the cost is such that that tracker is not going to make that charger like 1,000 times more expensive. So those are the cost trades that you would be thinking as an engineer or computer science or software engineer. All of those things come up in each one of those points of view. That's a little bit of a thought on that. Well, how about anybody else want to volunteer your project? We can do this kind of working with you over the next couple lectures.
Mine was number 10, magnetic slip-free shoes.
Okay. Well, let's have a discussion about that for now. Why don't you just first introduce the idea to the class, and we can start to do some research between now and our next couple lectures, and we'll unpack this some. Okay.
So basically, like the shoes are really mostly made for like older people, but like anyone can wear it. So it's basically like this idea of like, I don't know how to explain it. I wrote it down, but it's like on the bottom of your shoes, there's like these two sections that open whenever you fall, and it's like kind of senses when you're falling or are falling. So then it's like this magnetic force that like attracts each other, kind of like preventing you from falling or something like that. I don't really know how to explain it.
Well, first of all, thank you for sharing the idea, and I'm glad these are all interesting and different ideas. So as a class, we can benefit from that as a result. Trying to remember the one sci-fi series that I've been watching about, and it's like these folks that are mostly in outer space, and so there's low gravity, and what they do is they have these gravity boots. So when they're hitting the ground, because there's low gravity, they actually have a way of staying on the base of all of their living compartments and not floating away. That was the first mental picture that I was having with these magnetic shoes. But it sounds like it's not quite that. There's some other type of techniques, engineering / interesting technology features that are there. Is this something that you conceived, or have you found something on? Sorry? Okay. Well, like with every other project, what I would recommend is try and do some research. Where is the state of the technology for the components that would be necessary for this? And we'll be unpacking that. Another thing that I'll kind of tie in some of this with harness energy from the stars. And so that was another concept that we had come up with. And we were exploring, well, what type of energy sources might we be able to leverage? And so this is an example where I always like to say, when it's okay to brainstorm, when you're brainstorming, the laws of physics don't apply. I mean, just think creatively, just come up with the ideas. We'll fill in the details later, but just come up with what is the concept. And so this is an example of a concept, and now let's figure out where we can go with it. And we may end up having to morph it a little bit, which is perfectly fine, because we're still using the engineering and computer science methodology for us at figuring that out. So anyone have ideas that you could, let's talk about this one theme, this idea of magnetic slip-free shoes. Where do you think might be something that would be a benefit for that? Or maybe you have family members that you think might benefit from this, and maybe you have some insights from that we may want to have being considered. Go ahead.
Would your shoes work the same, like you see Michael Jackson do like
That's exactly what I was saying.
will they work like that?
I didn't think of that. Not really. It's more so like there are two different magnets, like one on the front of the shoes and one on the back. So like the shoes can kind of sense when you're about to fall, so you kind of like, I'm not explaining, like kind of force, like just what you call like that pressure of falling.
Yeah.
So then the two magnets are like contracting each other, so it's creating this force preventing you from falling.
Okay, so I would say that they're doing a couple things, and I'll just unpack it a little bit. So number one, it's a sensor to detect if a person has a higher probability that they're going to fall. Even, let's just kind of separate that from the rest. That in itself would be a useful feature, because then it could be a trigger to other technology that maybe that person would have. What? Yeah, life alert. Another thing that I've seen, but totally different, but just to give you a perspective, is like I saw a commercial about this this backpack that a motorcyclist could wear, and once they sense that he's a motion that does not correlate with normal riding a motorcycle, it immediately deploys the shield. It's like a big bubble, basically. It goes around the whole person so that they're not going to get injured or minimize the injury. So that I'm just giving you an idea. It's not your idea, but it's related to your idea. And so these are the things that started to get into this creative process, where there's a lot of things that start to come to the table. So number one, find out if these magnets is a sensor, and then could start to stabilize. If it could detect what needs to happen to counteract the instability that's going on, that would be the first thing. And so just think of a biomechanic trying to get the person's balance back online. That would be great. But there's then maybe some secondary systems that could get into not just trying to keep him or her upright, but then trying to get into some kind of protective mode of one sort or another. Like your car and you have an accident and you hit somebody else, and the bags deploy. So and those can be relatively small. So maybe these shoes might be a little bit larger than tennis shoes, but it has a little bit more technology that might be applied in one form or another. Okay. So why don't we continue to talk about this? And if you could, between now and our next couple of meetings, if you could do a little bit more research on that, and let's start to explore these related ideas that started to pop up. And guess what? There's going to be some software that's going to be needed for this. And so maybe this would be, maybe the controller would actually be an app on your phone, just to kind of have both not an engineering, but an engineering and a computer science feel to it. And so those are all, once again, choices that how much weight do you want on your shoes versus having it offloaded. If you could have a Wi-Fi or Bluetooth connection with another device that could offload some of that, including like Life Alert, that's how you actually get that communication out in one form or another, or Apple Watch or something else, a Fitbit or whatever. Are you guys getting a sort of an idea of what your project work is doing? And what we're trying to do in this course is it's one way to learn a material by going through lectures. It's another way of learning the material by doing. And I'm also trying to give you a chance to be experiencing the doing with our project work, and also having the conversations that we'll do in our class. Okay. Any other comments or questions that people want to have us go over? Okay, well, I think I've just about talked myself out, and I hopefully you guys find this interesting. Give me feedback. There is like a student survey that's just trying to give a pulse check early on. Let me know what's working, what's not, and how much you want me to focus on just lecture material versus doing this other type of ways of having us get into this material. Okay. All right. Take care, everybody.